is it a right triangle? So at first glance, when you look at this triangle, you may believe that it's definitely a right triangle. But unless we know that we have a right angle, which is what makes a triangle a right triangle, you need a 90-degree angle. If we are not told that, then we cannot just assume that it is. Because it's possible that this could be slightly off. It could be 89 degrees. It could be, 91 degrees. We don't know. So it has to be exactly 90 degrees. So what do we do in a case where we have a triangle and we're trying to figure out, is it a right triangle? So let's say we are given some information about this triangle. Well, before we get into that part, I want to first look at one of the conditions that, or a theorem that actually helps us to figure out if a triangle is in fact a right triangle. So let's say that this is a right triangle. So you're told we have a triangle that is a right triangle, meaning this is a 90-degree angle. And I'm going to make up just some general side lengths. So I'm going to say let's let this side be represented by the letter A. That's the length of this side. I'm going to represent the length of this side by the value of C. Or actually, let me make that into a B. So the length of this side is represented by B. So that's the length. And then the length of this side, let's call it C. And what I'm going to do is, using this side, I'm going to create a square coming off of that side. So I'll do my best freehand, square. And remember, a square means they have all similar side lengths. Or not similar, but they're the exact same length. So since I made a square where one of the sides has length A, and all the sides in a square have the same length, then that means this has to be length A as well. Then I'm going to do the same thing for this side. This has length B. So if I create a square off of this side, I know that each side is going to be length B as well. And then I'm going to make a square coming off of this side. And I can see here that since the length of this side is C, and this is a square, that means this has to have length C as well. And what I'm going to do now is I'm going to find the area for each square that I created. So the area for this side would be A squared. I'll just circle that area. The area for this square would be B times B, so that'd be B squared. And the area for this square would be C times C, which is C squared. So these are my three areas. And according to Pythagorean theorem, it gives us information. There is a relationship between these three areas. So if I look at the areas, the two areas, or the two smaller areas, which are the areas that form the right angle here, you can see that we have the right angle here. So these two areas are the ones that are attached to the sides that make that angle. So if I were to take those two areas, which is represented by A squared and B squared, well, if I add those two areas together, that's going to be equal to the area for this bigger square over here. And that's what Pythagorean theorem tells us. It's this relationship here that the sum, right, if I add these two up, the sum of the two smaller squares is going to be equal to this area over here. So you have to basically add up these areas to get this area. And again, it's important that these sides here, A squared and B squared, where A and B are the ones that form a right angle. So that's important. That doesn't matter what letters are really made up for this. It's just that the two areas you add up has to be the ones that form your right angle over here. Okay? So we're going to use this relationship. But before I use relationship, I want to put it into a more specific example. So let me group all this together here. And I'm going to make it a little bit smaller, so I can move it over here to the side. And what I'm going to do is I'm going to use this relationship to find the area for some triangle. So let me create this triangle here. And I'm going to look at side lengths 3 and 4 and 5. So this is a right triangle that comes up. This is a special right triangle here with side lengths 3, 4, and 5. And you could actually make a triangle with these side lengths. So I picked these numbers so just to kind of show you what I mean by this, using actual values instead of just letters. So what I'm going to do is create my squares off of each side. So here are all my squares. So 1, 2, and 3. So remember, this is a square and this is side length 3. That means the length of this side is also 3. If this is length 4, that means this has a length of 4. And if this is 5 and this is a square, that means this has to be 5 as well. Now when I find all these areas, 3 by 3 would give me area 9. A 4 by 4 square has an area of 16. And a 5 by 5 square has an area of 25. And I can see here, if I look at the relationship, it'll be true that, and I'll put the work up here, the two smaller areas, the ones that form the right angle, would be these two squares here. So 9 plus 16 is equal to 25. And you can see that that checks out. So, an important note to make is that Pythagorean theorem, it will only work for right triangles. So it only works for right triangles. So you want to make a note of that. That's very important. So it will only work for right triangles. It only works for right triangles. So you want to say that a whole bunch of times until you do not forget that. Pythagorean theorem only works for right triangles. So we're going to use that to help us out with the next part. So let's look at some examples here. So here we have a triangle. And in this triangle, I want to figure out, is it a right triangle? So since they gave me all side lengths, I'm going to be able to see if the relationship exists here. So does Pythagorean theorem apply to this? If a Pythagorean theorem works here, where we have that relationship where the two areas that form a right angle adds up to the other area, then we know that it has to be a right triangle, because, as I stated before, Pythagorean theorem will only work for right triangles. So I can look at here that I can see that this is probably the angle that would be considered to be my 90 degrees. So let's see, is this a 90-degree angle? So let's check. So again, I'm checking this angle here because I can see that this angle is less than 90. It's an acute angle. This angle is definitely less than 90. So this one looks like it's a right angle, but I don't know if it's exactly 90 degrees. So let's check. So in general, we said that Pythagorean theorem is basically a squared b squared and is equal to c squared. So add these two up. And remember, a and b represents the sides that form your right angle. So a and b in this case, the ones that form a right angle are these two sides here. Or we think this is a right angle, but that's what we want to check. So if I were to make my squares, and it doesn't have to be perfect squares as long as you have an idea, but this will be a 1 by 1 square, this will be a 2 by 2, and this one, since it's a length square root of 5, I know this length has to be square root of 5 as well. So if I find the area for each square, 1 times 1, I get 1 here. 2 times 2, I get area of 4. And here, square root of 5 times square root of 5. So if I did that work, square root of 5 times square root of 5, well, that's equal to square root of 25. Actually, let me do that work here on the side so you can see a little bit better. So square root, this is again side work. Square root of 5 times the square root of 5. Well, I know that that's square root of 5 times 5, which gives me square root of 25. And I know that the number that we used to multiply with itself is actually 5. So if you ever recognize this, that when you're multiplying square roots, we know that that's going to come out to be 5 in the end. So, just that's like a property, square root of a times square root of a. So if you have two square roots multiplied together where you're multiplying the same square roots together, the answer is just going to be a. So that might be, save you some time from going through all those steps. Okay, so that was my side work. So I know that this area is going to be 5. So now I can see that this area, which is 1, plus this area, which is 4, is equal to the area for the other side. So remember, 1 and 4 are the areas that form your right angle. So I know that this is my area. These two are the areas that form the right angle. And I can see that 1 plus 4, if I add those two, I get 5. And it is true, 5 equals 5. So since this is true, we know that this triangle is in fact a right triangle because we have a relationship where these two areas add up to this area. So now let's look at one more example. And yes, you probably already guessed that we're going to look at one where it doesn't work out. So let's see here. The angle that looks like a right angle would be this one here. So I'll put a question mark here. And I'm going to see now. Look for that relationship. Do the areas for the two smaller squares, the ones that form a right angle, add up to the bigger area? So if I look at this area here, then I have this area here, and this area over here. Well, this square would be square root of 5. That means this length has to be the same. If the length of this side is square root of 13, that means this length has to be the same as well. Again, these are all squares, so squares have the same side lengths. And if this is length 3, that means this has to have a length of 3 as well. Which means that this square would be area 9. This square, which we've seen in the previous example, square root of 5 times square root of 5, well, that's just going to be 5. So that was my side work. And then, if I look here, square root of 13 times square root of 13, well, I know that that's going to be 13 for this one. That's the area for that side, or for that square. And I can see that a squared, which is this square here, 9 plus the area of the other square is 5, should equal c squared, which is the area for the third square, the bigger square. And when I add 9 and 5, I get 14 equals 13, and this is not true. Since this is not true, we don't get the same amounts on both sides, meaning 9 plus 5 does not equal 13, then I know that this triangle here is not a right triangle. And the reason is because Pythagorean theorem does not apply to it. And according to Pythagorean theorem, these two areas, the ones that make your right angle, should be equal to the area of this third side when you add these two together. And since it doesn't work here, we know it's not a right triangle, because remember, Pythagorean theorem only works for right triangles. So if the theorem doesn't work, it's not a right triangle.